Hello, everyone. Today we are going to be starting Unit 4, which is all about rational polynomials. So obviously, if you look at the front page, you can kind of see a brief glimpse of what we're going to be covering this unit. But today we're going to be starting off with target 4.1, which is multiply and divide rational expressions. So, in simplifying, technically that's kind of involved in this. So as always, before we get started, if you guys could all give the Ignite problem, this problem at the top of the page, a shot, now's the time to do that. So pause your video and try and rationalize the denominator. All right, answers on the board. You should on this one, if we're going to rationalize by the denominator, that means basically multiply by the denominator, although we just switched the sign. So if you multiply the numerator and denominator both by 5 minus root 2, you're going to be left with, on the numerator, you're going to be left with 10 minus root 2 minus 5 root 3 plus root 6. Now, all of that, we would look to see if it simplifies, but none of those square roots are the same number. If these middle terms, if this had been a 2 root 2 and a 5 root 2, then we could do negative 2 minus 5, but they're not, so we can't. On the bottom, however, there are things that simplify, because when you multiply this out, you're left with a minus 5 root 2 plus 5 root 2, which at the end of the day, those simply just cancel. And all you have to do is obviously 25 minus 2, which leaves you with your denominator of 23, and nothing else simplifies. So that, as ugly as it is, that is your final answer. Now, today, this whole unit is really working with things that you have in the past. We're just taking it to the next level. So in order for us to talk about rational expressions, it first would help to talk about, well, what does it mean to be a rational expression? And simply enough, when we say a rational expression, all we're doing is we're talking about a quotient of two polynomials. Now, those polynomials can really involve pretty much anything. Anything as simple as like x divided by 3y. It could be anything where you are adding in some different length of terms. So if I had x plus 2 over x squared minus 3x plus 4, that would be a quotient. Pretty much anytime you're dividing. Like if I had 1 over 3, if we're going to be as simple as that, 1 over 3 is considered, obviously, a rational expression. And that's because you have a numerator being divided by a denominator. Now, we're going to kind of review a little bit, because we have kind of worked with rational expressions before, just not necessarily to the extent that we're going to. So if it's kind of like back in Unit 3, when we just divided simple individual terms, we divide each piece with what it's similar to. So for example, if I have a 2 and a 4, we can actually take 2 divided by 4, and we can simplify those right now. 2 divided by 4 ends up being 1 over 2. Variables, on the other hand, these guys we have to look at the exponents. Because if I have 5 x's on top and 2 on the bottom, what happens is if I have 1, 2, 3, 4, 5 on top, this is kind of the long way of doing this, oops, and 2 on the bottom. When you have something on the top that's also on the denominator, what happens is those reduce. 2 and 4 do the same thing. It's just if I break 4 up into 2 times 2, 2 divided by 2 cancels, and you're left with 1 over 2. So we're applying the same concept we do to numbers, we're just doing it with variables that we don't know what value they are. If I have 2 x's on the bottom, that's going to cancel with 2 on top, and that's going to leave me with 3 at the end of the day. And once you simplify all possible like terms, that means we're done. Now, if it's something like this, number 2, you have to look at the reason we were able to cancel those x's out in problem number 1 is because they were the same variable. It would be a different story if it was x to the 5th over y to the 3rd or y to the 2nd, because though that doesn't reduce. The only time things can reduce is when it's the same number being raised to that exponent. So it also applies to quantities. If I have an x plus 1, the only way and that's grouped together with parentheses, the only way we can cancel that out is with another x plus 1 somewhere on the denominator. So it's not like this x canceled with this x. That's not what's happening. Those parentheses, when there's addition involved, it groups those things together. So if I have this x plus 1, the reason I can cancel it out is because there's another x plus 1 on the bottom. You have something and you're dividing by itself, and that cancels. Now that plain old 2, there's no other plain old numbers, so that can't reduce, so that's going to stay on my numerator. On the denominator, the only way I could cancel out that x plus 3 is if there was an x plus 3 on top, and there's not. So that's going to stay as an x plus 3 on the bottom, and we are as simplified as it goes. Now, number 3 is the easiest one here. These x's, remember, if I have an x plus 2 on top, addition and subtraction group things together. So if that's an x plus 2, the only way that that would be able to cancel is if there was an x plus 2 on the denominator, and that's not true. We don't have an x plus 2 on the bottom. Because that's an x plus 1, that this piece, this problem right here, woo, that is as simplified as it gets. Now, sometimes, like example 4, sometimes you kind of want to work your way towards that. These polynomials right now don't reduce. If I have a 40x plus 20, there isn't a 40x plus 20 on the bottom. But if you factor these and we can break them up into individual pieces being multiplied, that will help you simplify at the end of the day. So if I factor the top, if we take out a greatest common factor, I take out a 20 of those two pieces. Well, if I take 40 divided by 20, that's going to end up being 2. And 20 divided by 20, that's going to end up being 1. Let's do the same on the bottom and see if anything can really, really cancel out. On the bottom, my greatest common factor out of a 10 and a 30 is going to end up being 10. So if I divide that out, 10 divided by 10 just leaves me with a 1x. 30 divided by 10 leaves me with a 3. And now let's look to see if we can cancel anything else. Quantity-wise, we can't. This 2x plus 1, there isn't a 2x plus 1 on the bottom. On the denominator, there's an x plus 3, but there's no x plus 3s on top. So those are definitely going to stay. But we have numbers. I have a 20 on top and 10 on the bottom. Do those reduce like a normal fraction? Yeah. 20 divided by 10 ends up being 2. And the quantities here, they just stay. Those can't cancel. So that would be your final simplified answer. You don't have to go ahead and multiply them back together. There are problems where I might, but for right now, we're just going to kind of be careful. Or not careful, that's next. But we're just going to kind of simplify it so. Now, what we just kind of talked about leads into this next step. And this is usually where, in this unit, this is the most missed thing that I see. Because this problem right here seems kind of self-explanatory, to be honest. A lot of students look at this, and when they see this x squared minus 2x minus 15, all being divided by x squared minus 9, a lot of students want to simplify this in one specific way. One sec, guys. How they want to simplify this is a lot of students want to go here and they want to say x squared divided by x squared cancels. Maybe you could say all of those are negative, so divide out the negative and those become positive. And a lot of kids want to tell me their final answer is 2x plus 15 all over 9, which is absolutely not how this is supposed to be done. That x squared is not just an x squared. Because we have that addition and subtraction sign in there, because this and this are here and this are here, those group things together. Addition and subtraction, that x squared is not just an x squared. On the top, it's an x squared minus 2x minus 15. All of those right now are technically together. The only way you could possibly cancel all of that out is either to break it up and factor it, or to find on the denominator another x squared minus 2x minus 15. Same thing with the bottom. If you want to cancel out that x squared minus 9, that means on the top there would have to be an x squared minus 9 somewhere in the numerator. And that's not happening. So how we are always going to simplify things is we always factor the numerator and denominator first. So in here, the numerator, this guy's going to factor pretty nicely. X times x gives me x squared. Now what goes here and here has to be something that multiplies to give me negative 15, but it also has to add to give me negative 2x. So what multiplies to give me negative 15 that adds to give me negative 2? Well, has to be negative 5. Ooh, sorry, my negative sign went crazy. And a positive 3. On the bottom, we have a perfect example of a difference of perfect squares. What squared adds to give me, or multiplies to give me x squared? Well, x times x. What multiplies to give me -9 that technically adds to give me a 0x? Well, that has to be a -3 and a +3. And now we can simplify. Because we've broken this up into a multiplication problem, now we have some smaller pieces that we could look to divide out. Now, we can only end up dividing out one of them because we have an x plus 3 on top and an x plus 3 on the bottom. So, final simplified answer is this. Because we don't have an x minus 3 on top anywhere, there's nothing there. There's no x minus 5 on the bottom anywhere. So that's about as simplified as we go. So what I want you guys to do right now, I want you guys to practice factoring. First, if you want to just start with factoring the numerator and denominator on this one, then pause your video now, and then you'll get to see the correct answer in just a moment. All right, final answer, you should have x plus 1 all divided by x plus 2. Now, if you didn't get that, it probably means that your factoring went astray. Typically, we always check for a GCF first. In both of these, numerator and denominator, GCF was 1. So the numerator should factor into x minus 3 times x plus 1. And then the bottom should factor into x minus 3 times x plus 2, in which case you have a quantity that ends up canceling. Right here, we're going to have an x minus 3 and an x minus 3. Those end up canceling out. And you're going to be left with x plus 1 over x plus 2. And since those aren't the same quantities, then those don't reduce anymore. That's your final answer. So what I want you guys to do now is I want you to, the bonus question, challenge question, I want you guys to try number 6 on your own right now. All right, final answer, you should add 2x all divided by x plus 3. And the reason is, now this one, just be careful, because sometimes the only way to factor is not necessarily just by factoring the trinomial. On the top, remember, if you can factor out a GCF first and be done with it, then yeah. The top, if you factored out a 2x, that was your GCF, you would have been left with an x minus 6. And coincidentally, that's one of the factors for the bottom polynomial. So because you have an x minus 6 and an x minus 6, those are going to end up canceling. And you're just left with a 2x on top and an x plus 3 on the bottom. So when it comes to simplifying those, when we multiply, it's kind of the same concept actually. Except for when we multiply, again, we want to look to see if we can factor. Now, if it's like something like number 7, when we're multiplying fractions, basically this is kind of adding in one step to what we just did. And if it's multiplying, it's essentially really just one big fraction, and it's being the multiplied, or the multiplication piece is kind of divided between the top and the bottom. Now, there's a lot of routes that you can go to simplify this. Some people combine it all as one fraction, and that's usually what I start by doing. I look at each of the individual pieces, the numerator and denominator separately, and I simplify what I can, and then I simplify everything together. So on the top, we have a 5. I would multiply this by any other numbers that are there, which there aren't any. X's, there's no other X's there, so I'm going to leave the X cubed. Y's, on the other hand, I have 1 Y here, and I have 3 here, which means I have a total of 4. On the bottom, the only number I see is a 15. I always move the number out to the front. X terms, we have 2 X's here, and I have 2 here, so I have a total of 4. And there's no other y's, so my y squared stays. Now, all we have to do is worry, since everything technically right now is already broken up into multiplication, I don't have to factor anything. I just have to simplify. If I, one sec, guys. Oh, we're back. That was fun. All right. So if we simplify my 15 and my 5 divided by 15, that reduces to really 1 over 3. You don't have to write the 1. Sometimes I will, just to get in the habit of it. For my x variables, I have 3 x's on top and I have 4 on the bottom. So all 3 of my ones on the top, all 3 of these are going to cancel with 3 of the ones on the bottom, and 1 is going to be left over. So for my x's, there's going to be 1 x left on the denominator. And then for my y's, same thing actually. For my y's, I have 4 on top and I have 2 on the bottom. So 2 of the ones on the bottom are going to cancel with 2 on the top. and 2 are going to be left over. So 2 y's are left on the top. And that's as simplified as we can go. Now, if it's something more complicated where you have quantities of things, and you know that again because there's addition and subtraction signs in this one. First thing that we look to do is we look to factor each of the different pieces. So if I look at this this first polynomial right here, let's see what that actually factors into. So first thing I'm going to do is take out a GCF. So it looks like both terms have a 2 and an x, in which case I'm going to divide both of those terms by 2x. 2x squared divided by 2x is going to leave me with an x. Negative 10 divided by 2 is going to end up being negative 5, and the x canceled out. And I'm going to leave the other polynomial with it because technically multiplication, remember, that's just one big fraction. On the bottom though, now let's factor out this guy right here. X squared minus 25, that can factor into an x plus 5 and x minus 5. It's our difference of perfect squares. Now if you want to, any quantities, I usually always kind of move to the end. If we have a 2x squared here, I can't really do too much with that. I'm going to move that kind of to the front. And now we look to see what we can really simplify. First thing I see is I have obviously 2 divided by 2. So those essentially right now, both of those are going to cancel. My x's, I have 1x on top and I have 2 on the bottom. So if we're talking leftovers, the 1 on the top is going to cancel with 1 on the bottom. So there's 1x left over on the denominator. If I move on, the next term that I see an x minus 5 right here. And we actually have an x minus 5 on the bottom. So those are going to cancel. And it doesn't look like anything else can cancel. This x plus 3, there isn't an x plus 3 anywhere else on the bottom. And this x plus 5, there's no x plus 5s on top. So those stay on their respective sides. X plus 3 stays on the top, x plus 5 stays on the bottom, and that's as simplified as we go. Now dividing is pretty much the same step, except for when you divide fractions, you guys will remember, dividing fractions is basically one step away from being a multiplication problem. When you divide by a fraction, dividing by a fraction just means multiply by the reciprocal. So this problem right here is actually equivalent to this problem. The 6n squared minus 18n all over n minus 3. Instead of dividing by this fraction right here, what we're going to do is we multiply by the reciprocal. The numerator becomes the denominator, and the denominator becomes the numerator. And now we're right back where we were before. Now, technically, this is really just one big problem. And all we have to do is factor each of these pieces and see what can cancel. So that is actually what I want you guys to do right now. I want you guys to try factoring each of these pieces, this piece right here, this piece right here, and this piece right there, and then try and simplify as much as possible. Go. All right, final answer. It actually ended up being pretty simple. You should have got n plus 1. Now let's see how we did that. First step is you should have factored obviously this first one. 6n squared minus 18n, all you had to do is take out a GCF of 6n, and you were left with an n minus 3. This part right here, n squared minus n minus 2, factors into n minus 2 times n plus 1. The denominator, this doesn't really do much, or you can't factor that anymore, so that just stays as an n minus 3. This guy, on the other hand, has a GCF of 6n, which comes out in front, and you're left over with an n minus 2 when you divide by 6n. Now, once you get to this step, now it's a matter of just looking for like things. Plain old numbers, we have a 6 divided by a 6, so that cancels out and makes 1. Plain old, just plain numbers, n divided by n cancels, and you're left with just nothing, just 1. N minus 3 cancels out with n minus 3, and n minus 2 cancels out with n minus 2, and you're just left with your final answer. If you want another practice problem, pause your video now and give number 4 a chance too. All right, number 4 actually turned out to be pretty nice as well. Final answer, you should have got 4 over 5. And the reason is, so if you start kind of working our way through factoring this, obviously 4x, that stays as your 4x. X squared minus 6x plus 8 factors into x minus 4 times x minus 2. On the bottom here, we have 5x minus 20. Here, we would take out a 5x, that's your GCF, or excuse me, a 5, so the 5 comes out. And if we divide both of those terms by 5, we're left with x minus 4. And then here your GCF ends up being x out of those two terms, so the x comes out in front. And if I divide both of these guys by x, we're left with x minus 2. So the factoring part is not meant to be anything crazy. It's just you have to really be careful of signs. Because once we do that, you're going to see that a lot of things cancel. X divided by x, that cancels out. X minus 4 with this x minus 4 cancels out. X minus 2 divided by x minus 2 cancels out. And 4 over 5 doesn't simplify anymore, which leaves us with our final answer. All right. So if you guys would like to give them a shot, I have a bunch of you try nows on the next page. So if you want to try some of these, we're going to go over a few of these in class. All right. As always, email Ms. Hardy if you have any questions.